Hi, Jada. Sorry, I forgot, but we're only on the first example. Okay. A is a set of positive integers less than 7, and we're trying to figure out the smallest positive integer that is smaller than 7. 1. Very good. Everybody gets that? And positive integer. So it can't be -1. 0 is not considered positive or negative, it's neutral. So the smallest positive integer less than 7 is 1. What's the next smallest? 2, 3, 4, 5, 6. Is 7 less than 7? No. So there's my set. Okay? Now if I want to draw those on a number line, I'll pick a spot for 0 because I see that I've got mostly positive numbers to put on. And then label my number line. And then because it's just the number 1, I'm going to go to the number 1 and put a dot on it. Closed-in dot around it, okay? And the number 2, a closed-in dot on number 2. And number 3, a closed-in dot on number 3, 4, 5, and 6. So there I drew it, and I said the numbers in it, but now I want to use this new thing called set builder notation, okay? So this is how I write that in set builder notation. So A is the set. And we'll always use X to represent our numbers. So the set of numbers, so this X stands for a number. This epsilon translates to belonging to So X is a number that belongs to the integers. So this Z, which looks like this, which I have a really hard time drawing, so I just do a Z with an extra line down. Okay, that's what stands for integers. A number belonging to the integer, so X is an integer as long as, now I want to say as long as it's between an integer between 1 and 6. So that's what we want to say here, an integer between 1 and 6. So that's called bounded. We know that we have a smallest and a largest. So our smallest is 1, leave space, and our biggest is 6. So we always go from smallest to biggest. Okay, and this is set builder notation. So put X in the middle. And this is called squeeze notation. So according to X, X has to be greater than or equal to 1, because 1's in the set. At the same time, it's less than or equal to 6. Notice the arrows point towards the window. Or point towards the as long as bar. Okay? So what does this say again? A is any number X belonging to the integers as long as 1 is less than or equal to X, which is less than or equal to 6. Which is another way of saying the X has to be greater than or equal to 1 and also less than or equal to 6. Okay? It'll get easier. Next one. B is the set of all integers greater than -3 but less than or equal to 5. Are we missing that page? First, all of us.
Yeah.
You are?
Yeah.
Set D.
Yeah, set D set of numbers greater than or equal to 6 and less than 6. Or 0 and less than 6.
I would just say B. No, we're missing a page. Okay. All right, let me pause this for Jada. Good thing we've got the whole of it. There we go. B is a set of integers greater than -3 but less than or equal to 5. So what is the smallest integer that fits in that set? greater than -3, but less than or equal to 5. Yep, -2 is the smallest. Because -3, it has to be greater than -3. So it's not, -3 is not in the set. And then the next smallest would be -1. So the clues in this are integers, and then greater than -3, but less than or equal to 5. So 0's in the set, 1's in the set, 2, 3, 4 is 5 in the set. Yes, because less than or equal to. You see that? Okay, so let's start before -2, so -3. And then we're going to color in just the dot above -2. Oh wait, -3, -4. This is not what's going on. So just the dot above -2, or the tick mark, -1, 0, 1, 2, 3, 4, and 5. That's what your number line would look like. Okay, just those distinct points in pairs. Now we want to write it using set builder notation. So again, we're going to start with x represents any number belonging to the integers as long as. Any number belonging to the integers as long as. So what's the smallest number in the set? -2. And the biggest number in the set? 5. Then x in the middle. And from x, we want to say it's greater than or equal to -2 and less than or equal to 5. Okay? Yes? Pretty good? Okay? There's another way to write, oh, I need the closing bracket. There's another way to write this set. I'm going to write it down, and you're going to tell me why this is also set B. And think about this statement up here when you're telling me why it's also true. It's another way to write the set using set notation. Yeah?
Because it just says less than 6, which would be 5, it doesn't say equal to 6.
Okay, so this says x is less than 6, but because we're talking about integers, the next integer less than 6 is 5. Okay? So because I don't have that equals there, these two sets mean the same thing, but only because I'm talking about integers. Okay? Cool. All right, next one. C is the set of natural numbers between 5 and 10. So see if you can write out C explicitly, with the smallest number in the set to the biggest number in the set. Hi. Oh, you're coming up. Do you mind photocopying?
Yeah, anything you.
It's 24. Thank you so
Yeah.
much. Okay, so who thinks they know the smallest number in the set? Yep, Gary? 6, good. Between 5 and 10. So not between and including, between 5 and 10. So 7, 8, 9 is 10 in the set? No. Okay. Right, so we can draw it. So let's start with numbers before 6. 3, 4, 5, 6. And then our tick marks are just going to go, for our dots are just going to go above 6, close dot, 7, 8, and 9. Those are the only numbers in the set. So see if you can write that in set notation in 2 ways. Does anyone think they have one way you could write that in set notation? Jack?
So C equals open bracket.
Yes.
E, and it's N.
Z. Oh, you use N? Okay.
In
Sure, you can use natural numbers.
the slash.
I don't know how to make the N look like that. I guess it's like that.
I
Yeah.
just did.
Yep.
6, and greater than or equal to.
Less than or equal to. Yeah.
Yeah. X, and then the thing again.
Less than or equal to 9. That's confusing for people, but when you start with the number, okay, so if you start with X, it does say X is greater than or equal to 6. Does everyone see that? But if you start with 6, and you gotta say 6 is less than or equal to X, they mean the same thing. Okay, 6 is smaller than X, or X is bigger than 6, means the same thing. Okay, that's one way. Anyone got a different way of writing it? Ava. Oh, you did naturals again, nice, okay. Yep. Less than 10? Nice. Okay, so this says between 5 and 10. So X has to be an integer greater than 5. So the first integer greater than 5 is 6. Okay, and less than 10. The next integer less than 10 is 9. Does everyone see that? You could have had Z's there. That would be fine as well. Okay. Anyone have something different? Okay, great. All right, when the word number is used without qualification, so they don't say integer, they don't say natural number, they don't say whole number, you assume that we're talking about the real numbers. Okay, so that means every little space filled in. Okay, so for each set described below, sketch the set on a real number line. So when it's a set of real numbers, it is impossible to list them out. Okay? Because there's an infinite number just between 0 and 1. So between 0 and any number, there's an infinite number. Okay, so it's impossible to list them out one by one, like that's impossible. Okay? So you have to use set over notation. It's your only way to describe it. Okay? So for each set described below, sketch the set on the number line first, so we have a really good picture in our mind of what the set looks like. And then write it out using set builder notation. So our first set is a set containing all numbers between -2 and 3. So we're going to start off with our number line. I want to be before -2, so like -5, -4, -3, and then up as far as I can go here, just like to 5. So all of the numbers between -2. So when we say between -2, is -2 in the set? No, but is -1.9999999 in the set? Yes. The way we show that is an open dot. Okay? Because -2 itself is not allowed to be in the set, but -1.9999999 is. Okay, because we're talking about real numbers now, not integers. Is 3 in the set? No. But is 2.9999999 in the set? Yes, so we need another open circle. And then we get our highlighter out, and we highlight in between. So everything in between is in the set. All those decimals, fractions, irrational numbers, everything in between is in the set. okay? So there's our set drawn for us. Now we want to write it in set builder notation. So we're gonna, this doesn't have a letter to call it, so we'll just use the set notation. And we'll say X has to belong to the real numbers, which is easy to draw, 2 sticks and then your R. As long as, and now we want to describe this set. And we do have boundary points again. The smallest is -2, even though we're not allowed to be -2, but we can use a strictly less than, okay, not less than or equal to, X, which is strictly less than 3. So that describes all the numbers, all the real numbers that are greater than -2 and less than 3. Okay? Set D is a set of numbers greater than or equal to 0 and less than 6. So we want to draw it on our number line first. Set of numbers greater than or equal to 0 and less than 6. So we're going to start off with, like, say, -2 here. So greater than or equal to 0. So is 0 in the set? Yes, because it says or equal to. So I'm going to put a closed-in circle on 0. Okay. Is 6 in the set? No. So I'm going to put an open circle around 6. But I'm greater than or equal to 0 and less than 6, so everything in between is part of my set. Okay. So now I want to write that in set builder notation. So set D is a set of all real numbers as long as the smallest number in the set is 0, and we're allowed to be 0, so we're going to 0 is less than or equal to X, which is strictly less than 6. And that describes that set. Every number between and including 0 up to 6, but not including 6. Okay? All right, the set of all real numbers greater than 0. So let's put 0 in the middle here. So is 0 in the set? Greater than 0, right? So like 0 is not in the set, but 0.00001 is in the set. Everyone see that? Okay, and then every number greater than 0 is in the set. So up to infinity, they're all in the set. So the way we show that is we go right to the end, and then we use our highlighter to make the arrow really big. Okay, so that shows all numbers bigger than 0 on the number line. How do we write that? This is a different set. All the ones we've talked about now are what we call bounded. They have a smallest and a biggest. Okay? This one has a smallest but doesn't have a biggest. Do you agree? Like, infinity, you can't define that. So this is how we're going to write it out. This is all real numbers as long as. So whenever you don't have a bounded set, you start with X. Whereas for all these ones, X is in the middle. Okay? So then compared to X, what do these numbers all have in common? They're greater than 0. Okay? So whenever you have an unbounded set, start with X. Okay? So because we're so used to doing that, a lot of people are going to say 0 is less than X, which is technically true, but it's not the conventional way to write it. okay? Set F is a set of all real numbers less than or equal to 3. Set F is a set of all real numbers less than or equal to 3. So we'll start maybe at -2. So is 3 in the set? Yeah, less than or equal to. So 3 is in the set, so we have a closed circle. And then to be in the set, you have to be less than or equal to 3, so this way. And draw all the way to the end, and then make a big arrow out of our highlighter. Okay. And then we want to write this set F using set builder notation. So we're going to say X is an element of the reals as long as it's unbounded, so we want to start with X and then describe how the numbers in the set compare to X. And look for clues. They have to be less than or equal to, less than or equal to 3, okay, to be in the set. Okay, the next one's interesting, the set of all real numbers except 0. Someone's a bit of a thinker. So is 0 in the set? No. So we're going to have an open circle around 0. But every other number is in the set. Do you agree? Every real number except 0. So that means all of these are in the set, and all of these are in the set. So that's what it looks like. And when you just have one number missing and every other number's there, there's an easy way to write it. Anyone have an idea of what that might be? X is in the set as long as? Perfect. X is in the set as long as it's not equal to 0. Okay, so every number not equal to 0 is in the set. Okay, set B is a set of all numbers between 0 and 1. Okay, so I want you to draw it and see if you can write it out in set notation. So as I walked around, I saw tons of people with an open circle around 0 and an open circle around 1, and then highlighted in the middle, so that's awesome. There's a little set. Pick a person. All right, who thinks they can write that set in set building? Yep.
Open bracket,
Yep.
X, epsilon,
Yep.
the real number symbol,
Yep.
slash,
Yep.
greater than 0, X,
So there's a 0 first.
yes,
Okay, and then less than X, which is
less than 1.
less than 1, perfect. Okay, how many people have that? Okay, good, good. Be proud of yourself, this is not easy. Okay, the set of all numbers that are less than -3 and all of the numbers greater than 1. This one's interesting, okay. So, let's go before -3 here, so. word and is underlined, so there's gotta be something a little special about this question. So all of the numbers that are less than -3, so is -3 included there? No, so it's gonna have an open circle. And all the numbers less than -3 look like that. Okay? And all of the numbers greater than 1. So is 1 in the set? No, so open circle. And all of the numbers greater than 1. So this is really 2 separate sets, okay? And you use the word union. So when you see and union, and the symbol to join 2 sets together or union is a capital U, ish, without the stick. Okay, that's the math symbol for union. So you're gonna just talk about the 2 sets separately and then put union in the middle. So the set of all numbers that are, so X starts first, strictly less than -3, union, so joined with the set of real numbers that are strictly greater than 1. Okay, so here's this set. This set goes with that part of the graph, and this set goes with that part of the number line. You join them together with a union symbol. Okay? Back of a textbook might write it like this. This is the most proper way to write it, but some of them will just put the union right in the 1 set bracket, which I don't mind, is fine with me as well. Okay? Because we're talking about the real numbers in both cases anyways. Okay? All right, so now we're going to do an example where we're going to start reading what that set notation means. So we want to draw the graph that goes with that set. So don't use your highlighter, and if you're not certain, but try, see what you think it would be, and then we'll see. Thank you so much. I'll be good this afternoon, the next one, yeah.
Okay, sounds good.
Okay, when drawing this set, how many people put a closed-in dot over -3? Yes. How many people put an open dot over 4? And then highlight it in between? Yes? Okay, good. So what's important to read here is, first of all, it's important to read what type of numbers we have, real numbers. Okay, so we know our highlighter is going to be involved. Okay, and then when you see that X is in the middle, you know we have a bounded set where we're going to have 2 circles either open or closed, and then highlighter in the middle. Okay, so the next one, look at this. This is not an R anymore, it's a Z. Okay, so that means just integers between -5 and 3, but there's less than greater than in there. That you have to worry about what it, sorry, there's an equal to here, but not here. See, this one's actually a good one to start. So when we're talking about integers, is it okay for me to put an open circle around -5? No, because we're not going right up to -5. The next integer that's greater than -5 is -4, and it is in the set, so it gets a closed circle. Okay? And then -3 is in the set, -2, -1, 0, 1, 2, and 3, and we're not coloring in between them because we're talking about integers only. Okay? Okay, we're back to real numbers again. See if you can draw that up. Okay, is -2 in the set? Yes, so closed circle. And then which way did you color? Towards the door or towards the window? There's the question. Door. Good idea. So to be in the set, you have to be greater than or equal to -2. Okay? To be in the set, you have to be greater than or equal to -2. All right, this one doesn't have, it's said in a different way. This is kind of like a back of a textbook answer, but see if you can interpret what that set is. X can equal 1, X is an element of the real numbers. Anyone want to describe what they drew here for this one? Jack?
An open circle above 1,
An open circle above 1, yes, agreed.
and then arrows going all the way to the end.
Both directions, yes. Okay, so every number except 1. Very good, okay. Here we've got a union. So this symbol is important. It means there's going to be two kind of separate sets on the same number line. And we're talking about real numbers again. Keep that in mind. Okay, so I see people have closed and dot around -2, which is awesome. And to be in this part of the set, you have to be less than or equal to -2. So that's this part of the set. And then open circle around 3, because that's be greater than 3. And so over here, that translates to that. Okay, x's that are greater than 3, strictly greater than 3. Any questions? Okay, right. All right, so now write each set of numbers using set builder notation. So this is actually highlighted, but you can't really see it. Okay, so write that up using set builder notation. There's an open circle around -2 and a closed one at 3. Okay, so we've got a smallest and a biggest for bounded, so you're going to start with x's and element of the reals as long as your smallest is -2, your biggest is 3, x is in the middle. You can't be -2, so you're strictly from x greater than, but from -2 less than or equal to x, and less than or equal to 3. Okay? So for bounded ones, put x in the middle and your arrows face the window. Okay. All right, how about this one? Oh, sorry, this one's interesting. So it's this, and then just this one, just the number 3, and this set. So it's 2 sets. Okay. Let me start this one. It's a bit weird. You don't see ones like that very often. But we will only see domain and range today. Have something like that. So first, let's describe the yellow set, we could call it. Remember, when it's not bounded, you start with x. So x is an element of the reals as long as x is, and then describe how the set relates to x. The numbers have to be less than -1. Okay? If you're in the set, if you're an x, you have to be less than -1. Okay? And that set's going to be union with, I can actually write out every number in that set, because the only number in that set is 3. Okay? Yep.
Is it acceptable if I just wrote x equals 3?
Union x equals 3, yeah, that's fine. Yep. Yep. That's fine too. Okay. So that is our intro to set theory. Why we're learning it is domain and range, which we're going to do next. But first, I got a little worksheet for you on just what we did here, set builder notation. Stop this and